Hey everyone. Yeah, welcome back again. I hope you have enjoyed your botany lecture a lot, and now it's time for your favorite subject, that's physics. Uh, am I audible? Just write in the comment section, please. Let me know if I am clearly audible. Yeah, class is being started. We are about to start this lecture. Let me know on the comment section, guys. Yeah, am I audible? Yeah, great. So, in today's discussion, as I mentioned in our last interaction, that we are first going to entertain the mathematical aspects so that this bridge course will actually help you bridging the fundamentals of the mathematical part which you have studied till your 10th class and the further maths which is actually required to study physics in the next 2 years. Apart from that, if any of you, like I expect that majority of the students are those students who have taken a transition from or about to take a transition from 10th class to 11th class. Okay, but still if any one of you or your siblings or friends are right now in from 11th to 12th phase or they are about to, even if they are about to appear for this year NEET examination also, this session and our upcoming session, that is use of calculus in phase 2, integration and integral calculus, and today's differential calculus and differentiation, these two sessions are going to be very much helpful and important for NEET exam. Alright, so even if you are this year aspirant or you are studying in the 12th class or else you are going from 10th class to 11th class, let's enjoy our session, and I'll try to cover as many fundamentals which are required for our further journey of physics. Sahi? So first of all, we are going to understand that what do you mean by use of calculus in physics, that too what is the meaning of differentiation and differential calculus. So see, number one, it's the mathematical portion, okay, basic maths you can say. Since it is a mathematical portion, you have to understand first of all its notation, what is its physical interpretation. What I mean by that is, if there is something, some maths, unitary method which you have heard from your childhood many times, that if one hand is having 5 fingers, the two hands will be having 10 fingers. So this is nothing but unitary method. Alright, so there is a significance that yes, it's a mathematical part, but where do we use it in science? You have used it multiple times. Alright, similarly trigonometry, logarithm functions, different type of graphical analysis, and in a similar way differential calculus and integral calculus are actually a very important part of physics. So I hope all are prepared and we are about to start this session. Okay, chaliye. So first thing is, we will understand the notation and meaning first, that what do you mean by differentiation, what is the meaning of differentiation and how do you write it. So doing differentiation is very easy. How to differentiate, when to differentiate, these two things are very much important and very easy. Okay, how to differentiate and when to differentiate, these are the important things and these are very easy. But right now we are just trying to see that how it looks like, what is the notation, representation and what is the meaning. Okay, so we are starting from the basic of the basic things. Okay, you will enjoy. See, first of all, if I write this dy by dx, let me, alright, yeah. Suppose you are writing dy by dx, you are going to find this type of notation many times in almost every chapter and every topic of physics now onwards. Okay, what is the meaning of this? You call it rate of change of y with respect to x. That means, suppose we say that position is changing with time. So how position changes with time, what is the rate of change of position with time in physics, we call it velocity. Suppose velocity changes with time, what is the rate of change of velocity with respect to time, that is called acceleration. Suppose acceleration is changing with time, we call it jerk. Similarly, suppose linear momentum P vector is changing with time, that is called force. So I'll give you examples, few examples for it. Example number 1, you say that your rate of change of position vector with time, d means, see, we'll talk about some d delta and all also. And you have to be patient, you have to keep some patience for a while, because again I'm telling you, this is the maths which is involved in physics. So maths ko we have to practice a lot, and then only we will be feeling highly comfortable. So see, there is a notation d which means small change, d means small change, and delta means big change, big change. Calculus is basically the study or science of changes, you can say, the mathematics of changes. You have to deal with changes, okay? Changes are of two types. D means small change, delta means big change. If you want to consider your big change into small parts, then in that case, you will be making use of differentiation. And if you want to add, sum up or integrate, the meaning of integration, the literal meaning, the English meaning of integration is also summation. For example, we can say India is a nature of cultural integration. India is a nature of cultural integration. That means India is that nation, that country in which you can find n number of cultures to be summed up. You can find all the cultures summed up in one country. All right. So the word meaning of integration is also summation. So here if we say that if we want to add small changes in order to consider the big change, the calculus or the mathematical tool which you are going to use is called integration. And if you are going to consider a big change broken down into small changes, then the mathematical tool which you are going to use is called differentiation. Okay. So if I write example number 1, dx by dt, dx means small change in x, suppose position, dt means small change in time. Okay. So dx by dt is going to give you v, which means how position vector, about the vectors you will be studying, you will be taking the guidance from Abhishek sir, that will be on Friday. Okay, this is Monday, we are discussing in differentiation part, differential calculus part. On Wednesday we are going to meet again and we will completely pack the integration part. On Friday you will be meeting with Abhishek sir, and he will be guiding you what the actual meaning of vector is and its applications also. Okay, so here dx by dt means small change in position vector with time, that is by definition called velocity. By definition that is called velocity. Okay, example number 2, dv vector by dt, that means small change in velocity vector with small change in time. Small change in velocity vector with small change in time, that is going to give you acceleration vector. Okay, one more example, Newton's second law. You remember Newton's second law? It talks about force and linear momentum. So the time rate of change of linear momentum is called, that will give you the force. So you will say dp vector by dt, that is called force. Okay, Newton's second law is that dp by dt is force. Fine. Similarly, some more examples which you generally see in which you have seen earlier also in your physics or in the other aspects of science. You have seen the power P is defined as rate of doing work or rate of dissipation of energy. So you will say dw means small work in small time, dw by dt, small work in small time, that will give you instantaneous power. Okay, that can also be written as de by dt. So if you are talking about a big change, big changes will give you average values. And if you are talking about small changes will give you instantaneous for that moment. It is quite obvious and logical also that if you are considering the changes for a moment, for an instant, then you are going to get the physical quantities for that instant only, and hence they will be known as instantaneous. And if you are talking about the big changes, the entire changes in the duration, then you will be getting the average values. Okay, so I'm gonna specify that also, that small changes are used for instantaneous values. Okay, small changes are used for instantaneous values and big changes are used for average values. Okay, so basic things you have to remember. So first question which generally we should ask ourselves is why there is a need of differentiation and integration? Why there is a need of differentiation and integration in physics? You know na, that majority of physics contribution is given by Newton, and Newton was not a physicist, he was a mathematician. Okay, so anyways, what is our learning from this thing is that if we want to have a great command on physics, basic mathematical part is actually required. And here we are going to study it in step by step with complete revision. The things which I want you to remember, I will keep repeating it. Okay, so we will study, we will practice, but most importantly, we will keep revising it. And that's my personal suggestion to all of you sweet students, that before you sleep tonight, whatever you have learned, let's try to make this a habit from this day. Whatever you have learned, try to have a quick recap, try to turn the pages before you sleep. Because whatever you are going to do in the last hour of the day, just before you sleep, that is going to be processed in your mind in a major, in a better and effective way. Okay, so that is scientifically proven also. Happens no, that if you see a cartoon, Doraemon, Pokemon, something like that, then you have dreams like that only. If you see horror movies, thriller movies, then you see dreams like that only. Similarly, if you are going to revise the things, okay, then these things will be processed at the back end of your mind. Okay, so in this way you can study when you are awake, and even if you are chill and sleeping, then also your mind is processing the things, and these things are actually useful. You know, so how to improve your efficiency, how to tune your brain in a more effective way, we will keep learning these things also. Getting back onto the topic, I was telling you that how do you say that, how do you perceive it, how do you understand it, that dy by dx is rate of change of y with respect to x, which means in a simpler way, I will be calling it as rate of change of numerator, rate of change of numerator, how numerator changes with respect to, WRT means with respect to denominator, which means you have a control over x, and you keep on changing the x, and correspondingly y will also keep on changing. You keep on changing x and y will also keep on changing. I will also call it differentiation of y with respect to x, with respect to, which means in accordance to x. You can also call it derivative. Are you getting it? I am just telling you the language, that if we teachers are going to use this language in front of you, you should not feel confused that, oh, sir is using too tough terminology. Okay, so we are just working on the terms, that derivative of y with respect to x. So differentiation, derivative, rate of change of numerator with respect to denominator, all these things are going to sum up for your differentiation notation dy by dx. One more important thing I would like to remember, although we don't use this thing at too many places, but once in a while you can get this type of problem, so be aware from it, be aware with it. That is, This can also be called as rate of change of, very much important, but rare problems come from this, rate of change of dependent variable with respect to independent variable. Now what does it mean? Dependent variable, independent variable. What is this, sir? We just know constant and we just know variables. We know constant, we know variables, we know coefficients. Now you are adding two more terms, dependent variable and independent variable. Trust me, you already know it. You just don't know the terms. Otherwise, now whatever I am going to do in front of you, you are pretty much familiar with it. You already know it. Now see, I will say, do you remember in 9th, 10th class, you used to have straight line equations? Suppose I say 2y plus 3x equal to 5. 2y plus 3x equals to 5. In this way, sometimes you used to express it as, see, I'll try to isolate x. So can I say 3x is equal to 5 minus 2y? If 3x is equal to 5 minus 2y, then x can be written as 5 minus 2y by 3. 5 minus 2y by 3. So here what you used to do? Here, if you express this straight line equation like this, you used to put the values of y as per your wish. And depending upon the value of y, the value of x used to come as an output. Remember, you used to supply y as the input and you used to get the value of x as the output. Okay, so what you will say that here, if we talk about the y, so see, you got x as a function of y. X as a function of y, so the value of x is going to be dependent on y. The value of x is going to be dependent on y, and just now I told you that differentiation or derivative means rate of change of dependent variable with respect to independent one. So here y is as per your mood, so independent of everything. Depending upon value of y, x will come. X will be dependent on y. Output will be dependent on input. So here in terms of derivative, d by d, d of dependent variable x by d of independent variable y is defined. Okay, you can find dx by dy. You can find dx by dy. Understood? For example, no sir, partially understood. Let's compare. We will understand it better. For the same option given to you of this straight line equation, few people can also express y in terms of x. They can write 5 minus 3x by 2. Y is equal to 5 minus 3x by 2. In that case, if you see that carefully, then here the value of x, we keep it as per our mood, independent of everything. So input will not depend on anything, but the output y will be dependent on the value of input, that is x. So can I say here y is given as a function of x, just like you used to represent the polynomial? No? So x as a function of y, y as a function of x. So y depends on x. Who depends on whom? Y depends on x. And you can write that d by d, but remember what I told you, that numerator may it should be dependent variable, with respect to denominator may it should be independent variable. Who is independent? X. And who is dependent? Y, because y depends on x. So we are going to say that it will be dy by dx, and that can be calculated. How it can be calculated? Again I am repeating beta, that doing differentiation, how to do it and when to do it, we are going to learn. That is very easy. Right now we are just trying to get the fear of basic mathematics out of our heart, that when we see this dy by dx, we should not panic. When we are saying dy by dx, it should clearly mean, it should clearly signify rate of change of one physical quantity with respect to another physical quantity. Alright, so I hope you are getting it. Just take a quick recap. Dy by dx, you can talk in terms of language, rate of change of numerator with respect to denominator, rate of change of y with respect to x, rate of change of dependent variable with respect to independent variable. And We can also say that these are the examples of signs which you have, where you have already implemented the differentiation part unknowingly. Alright, just see that, try to absorb it. In a minute we are resuming. I hope everyone is comfortable. Alright, so you should maintain the rhythm during our learning, during this journey of the bridge course, and definitely you should like, share and subscribe the channel and share this content with all of your friends so that we can learn together and we can compete together. Alright, chaliye. So this is all about the notation and meaning. What do we mean by differentiation? Don't worry, we are going to implement it very soon in terms of problems also. Okay. Next thing is successive derivatives. Successive derivatives. One by one, one by one, one by one. I'll just give you some idea. Where do we use successive derivatives? Alright. Now see. If we talk about the position x, position, and we differentiate it with respect to time. Differentiate it with respect to time, you will get velocity. Okay, velocity vector. You differentiate it again with respect to time, you will get acceleration vector, and all of them are vectors. Okay, so in general, whenever we are talking about the vector quantities, we make an arrow over them. Arrow. But I am not writing it multiple times because I told you that on Friday, Abhishek sir is going to guide you for vectors. Okay? Right now, you are learning with me for the calculus part. Alright? So, every teacher here is going to help you out up to the best level and hence, I suppose you are going to learn and enjoy the learning. Okay? So, similarly, if you differentiate it once again, then you will write it as jerk. And if I am going to represent in terms of notations, suppose I am going to represent it in terms of notations, so I will say velocity vector is equal to dx vector by dt, a rate of change of position with time. Similarly, acceleration, differentiate it once again, you will say dv by dt, or now be very, very careful. Be very, very careful. Here you can write differentiation of velocity one time. But if you start from position, then you have to do double differentiation. One time here, one time here. Double differentiation is represented by d2x by dt square. Once again, it is not, it looks like d square x by dt square, and it doesn't matter how you call it, right? But still I want you to call it as d2x by dt square. You write it in power only, and the meaning of this is only double differentiation. You have differentiated two times. For example, what I mean by that is, if y is given as a function of x, okay, I'm just telling you how to write it. Learning the differentiation we will see from the next slide. Okay, so if y is a function of x, then you remember I told you that y will be your dependent variable because that is the output. Output is a dependent variable because it depends on input, and input variable is a independent variable. Input variable is an independent variable. Okay. Okay, now where do we use this, sir? We don't like this much of maths. We are good with constant and variables. No, not like that. Okay, we have to learn this because sometimes in the problems in near future you are going to see these things. So right now the just terms are going on. Okay, so if y as a function of x, then in that case what you can say? If you want to write one time differentiation, one time. See, I told you that differentiation will be done of dependent with respect to independent. So, one time differentiation of y with y is dependent variable, numerator, with respect to x. that is denoted by, how to write it, sir? You write it as dy by dx, dy by dx, or f dash x. F dash x means, if fx is the function, f dash x means differentiation of this function with respect to x one time. Single dash Roman numerals means 1. Double dash Roman numerals means 2. Triple dash means 3. 5 if you want to write in Roman, you write it as v. 10 if you want to write in Roman, you want to write it as x. Remember, no? So this is just a notation. How do we write it, sir? 2 times differentiation. 2 times differentiation of y with respect to x. So you will say d2y by dx square, or you write it as f double dash x. 2 times in Roman. Similarly, if you want to write 3 times the differentiation of y with respect to x, or derivative of y with respect to x, you want to write d3y by dx cube. d3y by dx cube, it looks like d cube y by dx cube, or f triple dash x. I hope you are getting it. Alright. So if you want to see this, that position vector is given to you, you differentiate it one time, you will be getting velocity vector. Differentiate it another time, you will be getting acceleration vector. And differentiate it one more time, you will be getting jerk. Which means, if you want to write it as time derivative, so dA by dt, jerk is dA by dt, and here you can say, basically it is not in your syllabus. So this is out of syllabus for NEET. Okay? This is not in the syllabus, just telling you the notation, how to write it, So if something is dA by dt, forget about the name, If something is dA by dt, differentiation of A with respect to time. Differentiation of A with respect to time. From here, 1 step. From velocity, 2 steps. And from position, 1, 2, 3 steps. Which means, if dA by dt single time, then for velocity, it will be d2v by dt square. Because from velocity, you have to differentiate it 2 times to reach there. And from position, you have to differentiate it 3 times. So d3x by dt cube. I hope you are getting it. Till now, we have only learned what differentiation operator looks like, when to use it. When to use it, dear? When to use it? Whenever you want to talk about the small changes, or you want to talk about the instantaneous values. Small changes or instantaneous values, talk about differentiation. Okay? In different chapters, how to use the differentiation, with practice we will see that in every chapter. But now I am going to teach you how to differentiate. Okay? Just take a quick recap, take this, try to see this, whatever is written on the board for a while, for a minute. Then we are going to proceed. Just for a minute, see this. Yeah, few students have just joined. They are saying that, can you please repeat it? Dear, whatever I'm going to say further, that is going to be very much helpful. How to differentiate? Let's study from there. In the free time, you can prepone the session, or whenever you, you can, in the free time, you can just see the session from the start, and then it will be good. Okay? But as of now, don't worry. Whatever you have missed, it will be quite logical, but I'll try to inculcate it. I'll try to include it in our further discussion. So don't worry. Whosoever has just joined, just have some patience for a while. Going on. Okay? Chaliye. Let's move ahead. Now, we will talk about the basic formula. So, before learning how to differentiate, we must be knowing the basic formula for differentiation. That for different functions, what is the differentiated form? So, we will write, here we will write y as a function of x, and in front of that we are going to write dy by dx, or you can also call it as f dash x, single time differentiation. Okay, so single time differentiation we will learn, then we will see multiple times as per the demand of the question. Okay, so first formula, if we have x to the power n, then while differentiating it, its power will be multiplied and actual power will be reduced. Okay, power will be multiplied and actual power will be reduced. So n x to the power n minus 1. Example also I'll keep giving you. Example number 1, we can see that if y is equal to x square, then dy by dx will be equal to, see, power 2 will be multiplied and actual power will be reduced by 1. So that is simply equal to 2x, Getting it? Once more, let's see few more formula. If we have x to the power n, then it is power will be multiplied and actual power will be reduced. If we have something to the power x, see, here there was a number in the power of the x, and now the second function is there is x in the power of some number, then you write its derivative as a to the power x ln a. Ln a is basically natural log. Now what is logarithm, sir? What is log? Okay, about that we will be discussing later on. This natural log we are going to discuss later on. Fine. Right now let's focus on one by one different mathematical tools. So here the topic of discussion is going on differentiation. Now if we have e to the power x, then by rule it will be e to the power x ln e, but ln e is equal to 1, or that can simply be written as e to the power x, since ln e equals to 1. Why, sir? Why ln e is equal to 1? That will be discussed on the basis of properties of logarithm later on. Okay, log function, logarithm, anti-log, exponential, there is a lot to learn, but we are not going to learn it everything in one session. We will do it step by step, because things will be very easy. You just need to have a strategic preparation. Alright, so e to the power x derivative is e to the power x only. Fine. If you have a constant, what is the meaning of differentiation, sir? What we are learning since last so much of time, last 35-40 minutes, we have just learned the meaning of differentiation. Differentiation refers to the change, okay, change of numerator with respect to denominator. Now if you are talking about a constant is something that doesn't change. So if I am talking about constant and I am saying what will be the change in constant, so answer will be, sir, there is no change in constant. So what is the differentiation of constant? No change, sir, no change. So change is 0. So constant's differentiation is 0. Alright, remember it. Now another type of function, log x, basically ln x. That is ln x, natural log x. Its derivative is 1 by x. So these are the few formula. These are the few algebraic formula or logarithmic, exponential. Apart from that, I want you to remember what we majorly use in physics is, I want you to remember the differentiation of 6 trigonometric functions. Okay. So the differentiation of 6 trigonometric functions, which I want you to remember is sine, cos, tan, cot, sec or cosecant. Okay. So if you have sine x, then sine x derivative is cos x. If you have cos x, how to learn this, sir? Do remember that C family will have a negative differentiation, which means all the trigonometric ratio that starts from C, cot, cos, cosec will have negative answer of differentiation. That means cos x derivative is minus sine x, okay. I am not saying, dear, that left hand side is equal to right hand side. No. I am saying if left hand side is a function, its differentiation will be right hand side. If left hand side is a function, its differentiation is right hand side. Okay. Similarly, tan x differentiation is secant. Tan x differentiation is secant square x. and sec x derivative is sec x tan x, secant x tan x. Similarly, cot x derivative is minus of cosecant square x, and cosecant x derivative is minus of cosecant x cot x. Alright, these are the 11 formula. These are the 11 formula which you have to remember right now, and it looks big, but it is not at all big because we are going to practice a lot. So just try to learn it right now, and with whatever practice we are going to do in next few slides, you will learn it. Okay, everything will be memorized. Things are very easy. Then we will see the physics question. What type of questions come in NEET? What type of questions have already coming these days, and what are the problems expected in next 2-3 years? Okay, we will complete everything. Then you will see it was very easy. Don't know why for the entire 2-3 years students are too afraid of physics because of the maths involved. But the maths involved, if you do it strategically, it's gonna be very, very easy. Okay. Right, and sorry, I'm not just discussing. I couldn't see the comment section right now because I was in a flow, and I want you to learn in a flow. Once we are done with learning part and after seeing few illustration, I'll keep looking on the comments and I'll be replying to all of your doubts. Okay, but fatafat say, just quickly try to learn this. Learn this right now. What I told you is, and let me give you a few more examples also, so that everyone who has just joined recently, everyone will be comfortable. See, there is a very important property also. I'll try to tell that property in example 2. Suppose you have y is equal to 3x cube, then your dy by dx will be equal to dy by dx. Be very, very careful. You will say coefficients. See, there are 3 things. Constants differentiation is 0. If there is a coefficient, that will come out of the differentiation. And integration both. Integration too we will discuss on day after tomorrow, Wednesday. And variable will be differentiated because you are discussing the changes. So once you write d by dx of y means 3x cube. So you will say this 3 will simply slip out of the differentiation and integration both, and you are left with x cube. If you are left with x cube, which means this is the first function, when there is x to the power something, then that power will be multiplied and actual power will be reduced, which means that will be 3. This power 3 will be multiplied and actual power will be 3 minus 1. That means 3x square. So the final answer is 3 into 3, 9, and it is x square. 3 into 3, 9, and it is x square. I hope you understood something. One more example. Example 3. If we have y is equal to root x, y is equal to root x, then, and I want you to remember this. Okay, I want you to remember this illustration. I'll use some more space for this. Fine. Then dy by dx will be equal to dy by dx. This will be used in physics many times. Example 3 and example 4. Example 3 and example 4 are used in physics many times. If y is equal to 1 by x square, fine, then dy by dx will be equal to, okay. So I want you to remember these two because these are very common. These are very common derivatives which are found in physics. So obviously I will explain it to you. Obviously you will understand it. You will find it easy. But don't expect and don't tell sir I will do it in the exam. No. I want you to remember these right now. Okay? And right now the formula is in front of you. So after completing these 2 examples, we will be taking, I'll be waiting for you for a minute or 2 and you have to learn it. Okay? And we will be using our photographic memory. Anyways, we are watching a video lecture. So by means of our photographic memory, it will be helpful, you know, to understand and remember it for a long time. Now see, dy by dx will be equal to d by dx of root x means x to the power 1 by 2. Root x means x to the power 1 by 2. By the first rule of differentiation, by the first formula, you will say power will be multiplied and actual power will be reduced. Okay? Power will be multiplied and actual power will be reduced means 1 by 2 and x to the power minus 1 by 2. So minus power means it will be coming in the denominator. है ना. Negative power in the numerator means that will appear in the denominator, and power half in the denominator means root x. Okay, so what you can say, d by dx of root x differentiation is 1 by 2 root x. Root x differentiation is 1 by 2 root x. I want you to remember this. Okay, how it is coming, that is as per the formula, but ultimately the result you have to remember it right now. Okay, now next, if we talk about dy by dx of 1 by x square, so you will write it as d by dx of, see denominator mein x square means actually it is x to the power minus 2. है ना, denominator x square inverse x square means x to the power minus 2. So you will say as per the first formula, sir, power will be multiplied minus 2 and actual power will be reduced by 1. Power will be multiplied and actual power will be reduced by 1. So that is going to be equal to minus 2x to the power minus 3. So that is going to be minus 2 by x cube. Minus 2 by x cube. You can also find this. Fine. This is very common. Y equals to root x. Its derivative is 1 by 2 root x. And I think, see, the application of the formula, power will be multiplied and actual power will be reduced. That is in front of you. Alright. So now it's time to wait for you to learn all the formula right now, and don't worry, don't think sir is giving a lot of work right now. Okay, because once you try to learn it in a minute, then in the next 2, 3, 4 slides, we are going to practice it a lot. It will be learned right now. Then quickly we will see what type of problems come in physics. So try to do it. Try to learn all the formula, especially the trigonometric ones. I hope everyone is trying to learn. Power will be multiplied, actual power will be reduced. When it is something to the power x, answer will be something to the power x ln a. What is ln a? You call it natural log, and ln x means 1 by x. Its derivative, ln x derivative is 1 by x. Okay. And what is log exactly? We are going to discuss it later on in further sessions. Alright. Then I told you for trigonometric functions, you can remember C family's derivative is negative. Alright. These two I want you to remember. So let's maintain our pace. Cosec x derivative is minus cosec x cot x. Jay Lakshmi is asking cosec x derivative, that is minus of cosec x cot x. If it is looking a bit messy, so I'll write it neatly for you, no worries. Cosec x derivative is minus cosecant x cot x. Cot x derivative is minus of cosecant square x. Majorly you will use sine and cos. Sine derivative is cos, cos derivative is minus sine majorly. These are the basic formula. Okay. This looks hard. Yes, it looks hard in the at the first place, but doesn't matter. है ना? With the passage of time, everything which is a big thing, right, that will seem to be very, very easy. You know, whatever seems to be very tough, do it twice or thrice, yeah. It will be very easy. Okay. It's not going to be tough. I'll start with the physics question. You will enjoy it a lot. I'll start with the physics questions. Okay. Yeah. सही है, चलिए let's move on. Let's try to learn some basic rules of differentiation. So these were the formula of differentiation. If you want, you can take the screenshot. You can take the screenshot so that I'll tell you in a while to revise from the screenshot before starting the physics questions. Okay, I'll just get aside. Please take the screenshot. All right, chaliye, let's move on now. Rules for differentiation. There are basically 4 rules of differentiation. First of all, for addition and subtraction. For addition and subtraction. Addition or subtraction. If 2 functions are being added or subtracted, then what to do? For example, you can say if y is addition or subtraction of two functions fx plus minus gx, fx plus minus gx, then if you want to differentiate it dy by dx, then what you have to do is very simple. You have to differentiate both the terms independently, and then the plus minus sign in between will be as it is. That means fx derivative will be f dash x, okay, gx derivative will be g dash x, gx derivative will be g dash x, and if there was a plus in between, it will remain as it is. If there was a minus in between, it will remain as it is. Okay, it's very simple. In case of addition and subtraction, you just have to differentiate the two terms independently, and those two terms can be any from these. Those two terms can be any from these. The answer is exactly in front of you. So even if it look big, what do you expect? Can't we remember this list of formula in 2 years? Obviously we can. We can remember it in 2 to 5 minutes also. Okay na? Right. Chaliye. Coming back. If the two functions are in product with each other, product rule. Product rule, as it is clear, multiplication. Product rule is applicable for multiplication. It is also very easy. It is also very easy. It says if y is given by the derivative of two functions, product of two functions. If y is given as a product of two functions fx dot gx, then if you want to get the combined derivative, dy by dx will be equal to, listen to the process carefully, you have to differentiate one at a time. That means differentiation of the first one f dash x, second one as it is, gx as it is, no change in that, plus differentiation of the second term g dash x as it is, and no change in the first term. Alright. Differentiation of the second term and no change in the first term. I am telling you once, from the next slide I will keep repeating it. So whenever you find something tough in our session, don't feel, oh, how I am going to do it. No. This is the first time we are seeing that, we are looking at it, right? We will keep doing that multiple times, and things are going to be very easy. Alright. So we will say that dy by dx, the combined derivative will be derivative of the first one, second one as it is, plus differentiation or derivative of the second one, first one as it is. Okay, this you keep looking, you look for a while the other two rules also, then one by one we will repeat it, and then we will do multiple examples, so everything will be handy. Okay, so we have next rule as quotient rule. Quotient rule is for division. Quotient rule is for division. Okay, and what is that? We say if y is equal to fx by gx, if y is equal to fx by gx, then dy by dx is difficult to remember, but be a fighter. You have to remember. Okay? Be a fighter. You have to remember. One by one we will see that once again. It will be easy. See, dy by dx will be equal to denominator में denominators square. Denominator में denominators square. No other change. Numerator में numerators differentiation. Numerators differentiation. Denominator as it is minus denominators differentiation g dash x, numerator as it is. I repeat, denominator may in the denominator, whenever it is written by numerator by denominator, written as numerator by denominator, which means you are talking about a division. That rule is called quotient rule. And what you have to do, you have to square the denominator term. You have to square the denominator term in the numerator. Numerator's derivative, denominator as it is, minus denominator's derivative, numerator as it is. Speak with me. Denominator will have denominator's square. Speak with me. Be a kid while learning. Denominator will have denominators square. Okay, it's denominators square. Numerator will have numerator's derivative, denominator as it is. Say, numerator will have numerator's derivative, denominator as it is, minus denominator's derivative, numerator as it is. Denominator's derivative, numerator as it is. Understood? It is difficult to remember, but we are fighters. Okay, so we will remember it. And we will see that multiple times. But before that, let's not ignore the full and final rule and the one of the most important, chain rule. Chain rule. Most difficult for students. Students find it tough. Students find it tough, but that's my favorite. My personal favorite. Okay, so why it's my personal favorite? At right time I will tell you that why it's my personal favorite. And when it is used, this is used for composite functions. When one function is going inside the another function, another is going inside the another one, first inside the second, second inside the third, like that. Right now not taking it, otherwise you will be fearing from it, right? So okay, so this is just a slide for your revision in which I told you how to do and when the rules will be applicable. In addition and subtraction, you have to differentiate the individual one and plus minus will be kept as it is. In multiplication, one at a time, differentiation of the first one, second one as it is, plus differentiation of the second one, first one as it is. And in case of quotient rule, you will say that it is denominator will have denominator square, numerator will have numerator's derivative, denominator as it is, minus denominator's derivative, numerator as it is. Okay, so let's start our journey one by one from all of that. First one is for addition and subtraction. Addition and subtraction, we will say, again I'll write it for you. I said if y is equal to addition and subtraction, one by one again I will write, if y is equal to fx plus minus gx, then dy by dx will be equal to f dash x plus minus g dash x. What does that mean? That simply means that what you have to do is you have to differentiate them individually, then keep the plus minus sign as it is. I'll give you a very simple example for that. Example number 1. Suppose y is equal to sin x plus cos x. Okay, first example hai, but I will give you multiple steps in that. Then here if I am asking you dy by dx, okay, so you will say differentiation of sin x. What is the derivative of sin x? Cos x. Plus what is the derivative of cos x? That is minus sin x. Okay, you can keep referring to the screenshot also. Okay, that derivative of sin x is cos x and derivative of cos x is minus sin x. Final answer is cos x minus sin x. Cos x minus sin x. Okay, cos x minus sin x. See, I didn't change this plus sign. This plus was replaced by minus because of the formula that plus into minus is minus. Okay. Similarly, if we say, sir, differentiate it one more time. So first time derivative looks like dy by dx. Second time derivative will look like d2y by dx square. Okay. Let's see. You will say, sir, cos x derivative you should write here. Minus will be as it is. Sin x derivative you should write here. So what is cos x derivative? Minus sin x. And what is sin x derivative? Cos x. So if you look at it carefully, that's minus of sin x plus cos x, or that can also be written as minus y. So minus y. Why, sir? Because y was sin x plus cos x. If y was sin x plus cos x, you had minus y. Okay. So what else? So similarly, you can keep on differentiating it. One time differentiation is this, second time differentiation is this, third time differentiation will keep on happening, third time, fourth time, fifth time, like that. Okay, so this was example number 1. Sine and cos, I told you, very common. Example 2, suppose if we have y is equal to e to the power x minus ln x plus 2 to the power x. Okay, then dy by dx is dy by dx is equal to, you may feel that it is a very complicated function, but I told you na, that doing differentiation is very easy. What is differentiation of e to the power x? That is e to the power x. See, I already gave you the list of the formula. What is the differentiation of e to the power x? That is e to the power x only. Okay, e to the power x only. Fine. What is the differentiation of ln x? That is 1 by x. And what is the differentiation of any number to the power x? That is a to the power x ln a. That means just substitute the formula. E to the power x derivative is e to the power x individual differentiation minus sign as it is. Ln x differentiation is 1 by x plus sign as it is. 2 to the power x differentiation is 2 to the power x ln 2. The way you had there, a to the power x differentiation is a to the power x differentiation is a to the power x ln a. So 2 to the power x differentiation is 2 to the power x ln 2. 2 to the power x ln 2. I hope that is clear. Now you can tell me. Now you can tell me in the comment section. I'm looking at it. It's a super interesting class. Thank you. Thank you so much. It is all for your learning only here. Right? So just tell me, is this step clear? I have not done anything complex. I have just substituted the formula that e to the power x derivative is e to the power x. Then ln x derivative is 1 by x and 2 to the power x derivative is this. I can see there are a lot of viewers, but I would like to understand that whether you are understanding it or not. Are you getting it? Right? If sir, can't we write inverse of minus 2x cube? No. It's not about that what we can write. It's about which formula is to be applied. For example, एक और example लेते हैं. Let's see one more example. Example 3. If suppose we say the plus minus sign in between as constant. Okay? Let's see. Let's talk about one more example. Example number 4. Suppose y is equal to x cube minus 5x square plus 10 by x. X cube minus 5x square plus 10 by x, or let's take it 10x. 10x plus 3. Okay, 10x plus 3. You can see cubic, you can see quadratic, you can see linear, and you can see constant. Cubic term, quadratic term, linear term, and constant term. Okay. In that case, if you want to get the value of dy by dx, that will be equal to, see, power has to be multiplied, actual power has to be reduced. 3x square, power has to be multiplied, actual power has to be reduced. Minus as it is, this 5 is acting as a coefficient. Coefficients simply slip out of differentiation and integration. So this 5 will slip out and x square derivative is 2x. Plus this 10 will also slip out because this is coefficient. And x derivative with respect to x is 1. I repeat, x derivative with respect to x is 1. You can all remember it like this. D by dx of x. Anyways, dx same, answer is 1. D by dt of t. Anyways, dt is same, answer is 1. D by dm of m. Answer is 1. Alright. See? So, x cube derivative is 3x square minus 5 will simply stand there. X square derivative is 2x plus 10 will stand as it is. X derivative with respect to x is 1 plus constant's derivative. 3 is a constant. Constant's derivative is going to be 0. Constant's derivative is going to be 0. Alright. So that's going to be equal to, what is your final answer, dear? Your final answer will be 3x square minus 5 into 2x, which means minus 10x. 3x square minus 10x plus 10. 3x square minus 10x plus 10. I hope the examples as well as the first rule is very much clear to you. And don't forget to revise this before you sleep, because this might be the first time you are studying the differentiation part. You must be revising it. Then you will enjoy. Okay, just see that carefully. Let me know in the comments if you are having any kind of doubts. I'm looking at the comment section now. Let me know. Feel free, be frank, whatever is your doubt regarding this as well as the bridge course and even regarding our campus, feel free to talk. There might be multiple thoughts coming in your head that, can't we use this formula? Can't we use that formula? So I precisely described that there is a set rule of formula, 11 formula. So obviously in a journey of 2 years and in fact 2 to 5 minutes, next 2 to 5 minutes, if you look at the formula, list of formula carefully, you are going to crack it. Okay? Coming back. Just see and let me know if there is a doubt. Sir, explain example 3. I'll explain example 3 once again. I just said that root x derivative is 1 by 2 root x. If you have just joined the session, dear, then you can remember this. This is very common in physics, that what is the derivative of root x? The derivative of root x is 1 by 2 root x. And x square, as I did here, x square derivative is 2x. So here also x square derivative is 2x. I hope that's clear. Sir, what is d by dx of f of g of x? Yeah, Guru Murthy. Dear, that is done by chain rule. Have patience for a while. In next 10-15 minutes, I think we will be practicing chain rule in a very well way. Okay? I hope now everyone is clear with all the examples. Okay. Chalo. Taking you to the next rule, that is rule for multiplication. In fact, rule for multiplication and rule for division are bit rarely used, and we have a limited time for this session. So let's talk about the doubt which Gurumurthy just asked. Sir, what is d by dx of f of gx? The chain rule. I'll take up the chain rule and then we will see the problems, and whenever product rule and quotient rule will be required, I'll come back, I'll explain it to you, and then we are going to proceed. Let's start. Right, and don't forget, dear, whosoever has joined right now, you have to revise this. You have to revise this from class notes, and class notes can be downloaded from the description. There is a link in the description, and that will also be shared on the Telegram group. So don't forget to join the group. Okay, dear? And yes, yeah. Chaliye, let's start with chain rule for composite functions. That is, if y, I'll just give you an example. Chain rule is fight sequentially. Sequentially means that is in a sequence. In a sequence, one by one from the outermost. In a sequence, one by one from the outermost. What is the meaning of this thing? See, if I say that there is a function y which is f, and inside the f there is not x, it is g, and inside g there is not x, there is h, and then there is the x. Alright, that means if you look at this function, which was the doubt of one of the students here, that is x is going inside h and hx is going inside g and g of hx is going inside f. It looks very tough. So I'll give you an example. Okay, example also side by side. Example number 1, if y is equal to sine square x. If y is equal to sine square x, that is, you will say sine x whole square. Okay, sine x whole square is basically sine square x. Sine x whole square is basically sine square x. Okay, so what you can say? Then its differentiation is d by dx or dy by dx is, you have to fight sequentially. You have to fight sequentially means one by one, you are going to differentiate all the functions. While differentiating the outermost function, leave the inner functions untouched. Don't touch them. For example, let me write the rule later on, because rule looks very tough. And what you will do with the symbols, you have to know how to differentiate it. Okay. Then you will write here dy by dx, that is equal to First of all, you have to fight with the outermost function. What is the outermost function? Square function. And what you do with the square function? You multiply the power and actual power is reduced. You multiply the power and actual power is reduced. But story is not yet over. This is only the outermost function. Now you have to go inside one and all the terms will be multiplied. Remember dear, in the rules slide I told you, that in case of addition subtraction, intermediate sign will remain intact as it is. In case of product rule, there will be a plus coming. In case of quotient rule, there will be a minus coming. Product rule में plus coming, quotient rule में minus coming, chain rule में multiply coming, dot dot dot. Chain, link 1, link 2, link 3, differentiated term first, differentiated term second, differentiated term 3. Now you have to join all of them in order to get the complete chain. So you will say it will keep on being multiplied. So derivative, how you take the derivative of the outermost function? Power will be multiplied and actual power will be reduced. This is very much important, very much important. Then inner function is sin x. Sin x derivative is cos x. Sin x derivative is cos x. And if you get inside it, then x. X derivative with respect to x is 1. X derivative with respect to x is 1. Now this is your final answer. This is your final answer. So that can be written as 2 sin x cos x. Okay, G. And later on we will study that can also be sin 2x. How that can be sin 2x? Later on we will study in trigonometry. Later on we are going to study this in trigonometry. Okay. Let's take one more example. Example number 2. If y is equal to sin x square, then dy by dx will be equal to, you will say that outermost function is sine function. This time the square is not applied for the complete. This time the square is only applied for the x. So you will say outermost function is sine function. Fight with that sequentially in a sequence. Sine functions, fighting means differentiation. Sine functions derivative is cos. Sine functions derivative is cos, and don't touch the inner one. Don't touch the inner one. X square will be as it is. Then you go inside. X square derivative is 2x. X square derivative is 2x. Then you go inside. What is the innermost one? X. X derivative with respect to x is 1. So the final answer is 2x cos of x square. 2x cos of x square. Okay. Okay. Very good. Very good. Few students are answering side by side. That's very good here. Next question. Example 3. Suppose we say y is equal to sine of sine square x cube. Sine square x cube, or can I also write it as sine x cube ka whole square? Sine x cube ka whole square. Then you will write dy by dx will be equal to, be very very careful. You will say outermost function is not sine function, outermost function is power function. So power function's differentiation is power will be multiplied. Don't touch the inner one will be as it is. Power will be multiplied and actual power will be reduced by 1. Okay, this is the outermost function differentiation. It will be multiplied by inner function. Inner function is sine function. Its derivative is cos, and don't touch the innermost. Then the next term will be the differentiation of x cube, that is 3x square. And now get inside it, x derivative with respect to x is 1, and all such 4 terms will be in multiplication. Okay, chain will be formed by link into link into link into link. Multiple links will be multiplied in order to get the complete chain. I hope the chain rule is clear and this doubt is also clear. Not complicating it by writing the symbols in front of you, otherwise you will be scared. Just try to learn that how to do the chain rule differentiation. When to do, sir? When one function is standing inside the other and that is standing inside the third one. Alright, or fourth one and fifth one, like that. And how to do it? You have to just differentiate the terms in a sequence while differentiating the outermost function. Never ever touch the inner ones, and so on. This will keep on happening. One more example. See, Example 4. If y is equal to x to the power, or you can say tan of ln of e to the power or x square, like that, tan of ln of x square, okay, tan of ln of x square, then you will say dy by dx will be equal to just after this we are going to start the neat questions, that what type of questions came and what are going to come. Okay, so dy by dx of that will be equal to, which is the outermost function? Outermost function is tan function. Its differentiation is secant square, and don't touch the inner ones. Now ln's differentiation is 1 by x. So ln x square is 1 by x square. All right. Now get inside that function. X square derivative is 2x. All right. Now you can see x will be cancelled by one of the x power. So the final answer is 2 by x secant square ln of x square. All right. So this is how you get the value. This is how you operate the chain rule, and you can get the value of differentiation of composite functions. All right. I can see in the comment section that few of you are trying to do the things, and hopefully you will be enjoying. It's easy, no? Differentiation is relatively very easy, and integration is also easy. It's just that you need to know that how to differentiate is easy. When to differentiate is the question in the physics. How to do the integration is easy, just like differentiation. We will learn in the next lecture. When to do it is a question. I hope that is in front of you. Take a minute to revise the chain rule, and then we are starting with the questions. Sir, please explain example 4. Okay, I'll explain example 4. Example 4 may it might look like to you that tan and ln are multiplied, or multiplied with x square, but that is not true. See, it's not. You need to understand that it's not equal to tan x. It's not equal to tan x ln x x square. It's not equal to this. Okay. These are the three functions in multiplication. Or product. But these are the three functions, one inside the other. X square is going inside ln, and ln x square is going inside tan. So this type of function, I call them the composite functions, one inside the other, another inside the other, like that. Then how to differentiate it? Fight sequentially means differentiate one by one. So differentiation of the first term will be as it is. Differentiation of first term, tan functions differentiation is secant square. Inner functions will be as it is. Then you have to go to the differentiation of ln x square, that is 1 by x square, and x square will be as it is. And then you have to differentiate the x square, that is 2x. If you are forgetting, let me give you a reminder. Ln x derivative is 1 by x. So ln something's derivative is 1 by something. Okay. Sir, can these classes say on campus once again or not? Definitely these will be said in the campus once again. This is just the free of cost bridge course for all of you, not to waste the time in these vacations, but to groom yourself and to tune your mind for your big day preparation. Alright. So इसीलिए that's why I'm saying that everything, right? Let's try to learn. Let's try to make every day productive. But once you are getting into the campus, these things will be taught to you. Okay? So don't worry about it. But definitely something is always better than doing nothing. So let's do it. And hence, with the passage of time, we will keep on getting more and more comfortable with the topic. I think example 1, example 2, guys, if you are going to ask one by one all examples to me, then how we can proceed? Chalo, with the passage of time, I'll try to explain one by one all examples to you. Let me give you few questions as of now. Okay, let's try to do few questions. For example, there is a question. Already a neat PYQ. Let's try to understand it. And let me see whether it is clearly visible or not. Write down in comment section. Is it clearly visible? Notes will be provided on the Telegram group, guys, and you can see the links in the description of the video also. I'll also see and edit that once the session is over. Clear? Alright. Chaliye. Let's see what the question is saying. Question is saying two cars P and Q starts from a point at the same time in a straight line and their positions are represented by this. So for car P, you have XP represented as AT plus BT square, and for car Q, you have XQ represented as FT minus T square. Fine. What they are saying? They are saying these are the positions. At what time do the cars have the same velocity? At what time do the cars have the same velocity? So let me write the general equations of motion for you. General equations of motion. V equals to dx by dt. A equals to dv by dt, which I have told you on the first slide and first few minutes of this session. Also, A equals to v dv by dx. Try to remember this. A equals to v dv by dx. Try to remember this. So you are supposed to remember these three equations. General equation of motion, very common questions, like commonly you can definitely get a question from this. So v equals to dx by dt, a equals to dv by dt, and a equals to v dv by dx. Now you see, if they are talking at what time do the cars have the same velocity, let's try to get the value of velocity. Vp, that will be equal to dxp by dt. है ना? What is that? A will stand as it is, t's derivative with respect to t is 1, plus b will stand as it is, t square derivative with respect to t is 2t. So that is equal to a plus 2bt. Similarly, if you are going to write the velocity of q, that is going to be dxq by dt. So f will stand as it is, being a coefficient, t's derivative with respect to t is 1 minus t square derivative with respect to t is 2t. So what you are getting is f minus 2t. And they are saying at what time their velocities are equal. So at what time their velocities are equal, which means Vp equals to Vq. So you will have a plus 2bt will be equal to f minus 2t. Let's swap the term. Let's send this 2t term here and a term on this side. So you will be having 2bt plus 2t, and that will be equal to f minus a. From here t can be taken common, or 2t can be taken common, that is b plus 1, that is f minus a. So what is the time which you are getting, dear? That is f minus a by twice of b plus 1. F minus a by twice of b plus 1. Let's choose if any option like that is there. F minus a by twice of b plus 1. See, option A is absolutely correct. Understood? So what we have learnt is, first of all, we have seen that they are giving you the positions, talking about the velocity. So if you differentiate the position, one time you will get the velocity. Remember what I told you? I told you if that's the position, differentiate it one time, you will get velocity. You differentiate it another time, you will get acceleration. Right? Position to velocity, velocity to acceleration, differentiation. And if you will integrate, differentiation and integration are opposite processes. If you will integrate acceleration, you can comment about the velocity. And if you integrate the velocity, you can talk about the position. But integration though we will do in the next interaction. I hope it is clear to you. You can take the screenshot also. Understood? How to get the idea of the velocity from the information of position, then equating the velocity, because they asked at what time do the cars have same velocity. Alright, right. Let's move on. Let's talk about the next example. They are saying the position of the particle varies with time t as x equals to at square minus bt cube. They are asking you the acceleration of the particle will be equal to 0. the acceleration at time t of the particle will be equal to 0. What is that time t? So see, from here, from where you have to start, x is given to you as a t square minus b t cube. How you can talk about the velocity? Differentiate it once, dx by dt. What is that? It will be, a will be standing as it is, sir. T square derivative will be 2t. Minus b will be standing as it is, sir. T cube derivative will be 3t square. Getting it now? Power will be multiplied and actual power will be reduced. Okay. So this is 2at minus 3bt square. 2at minus 3bt square. But sir, we want to talk about acceleration. So you have to differentiate it once again. A equals to dv by dt. A equals to dv by dt. That will be equal to, you will say 2a will stand as it is. T's derivative with respect to t is 1. Minus 3b will stand as it is. T square derivative is 2t. Alright. So that is equal to 2a minus 6bt. Now what they are asking? They are asking acceleration is 0. For acceleration to be 0, we have 2a minus 6bt. This must be equal to 0. From here 2a is equal to 6bt, or t will be equal to 2a by 6b or a by 3b. 2a by 6b or a by 3b. Alright. 2a by 6b or a by 3b. Option C is absolutely correct. I hope that is clear to you. A by 3b. Alright. Any doubts? See, sequential differentiation. Very simple addition and subtraction rule only. They gave you difference position, you differentiated it, you got velocity. You differentiated and got the velocity, differentiated once again, you will get the acceleration, and hence they are asking you when the acceleration will be 0. Easy questions. These are also NEET PYQ. Okay. Okay, there is no link. Botany class description link is there. I'll also see here. I'll also see. Just give me few minutes. Let's complete the session. After the session, I'll give the Telegram link in the description. Okay. We can give it in this video also, sir. Sir is saying this will be provided. Okay. Don't worry. Chalo. Let's complete the session with next two problems. Next problem is, the motion of a particle along a straight line is described by the equation. See, equation is given to you. So I'll start with that. What is the equation? X equals to 8 plus 12 t cube. Okay. This I think t cube is a typing error. T cube, it's a typing error. It should be 8 plus 12 t cube, I believe. Take what they are asking. The retardation of the particle. Retardation means negative acceleration or speeding down situation when its velocity becomes 0. Retardation when its velocity becomes 0. So first of all, I'll find the velocity. That will come out to be dx by dt. So you will say constant's derivative is 0. 8 is a constant. Constant's derivative is 0. 12 is a coefficient that will stay out of differentiation. T cube's differentiation is 3t square. Okay, t cube differentiation is 3t square, 3t square. Fine. So that is equal to 12, 3, 36 t square. And they are saying the retardation of the particle when its velocity becomes 0. So for v to be equal to 0, can I say 36 t square is 0? This implies t is also equal to 0. Okay. Now, if we are going to find the acceleration, that is dv by dt, so you will say you have to differentiate this 36 t square because that was velocity. So 36 will come out and t square derivative is 2t. So that is 72t. But they are asking you, so acceleration when velocity is 0, that means acceleration at t equals to 0. Because velocity was 0 at t equals to 0. So that is 72, and t at t equals to 0, you can simply put 0 in place of t and answer is 0 meter per second square. That is 0 meter per second square. Okay. So the correct answer is, as you can see, the correct answer is option D. Fine. You have to find out the time at which the velocity is 0. And once you got the time at which velocity is 0, at the same time you have to find the acceleration. Fine. Is that clear? And now it's time for our last problem. I hope that is clear to you. One more problem we'll do. Okay. Last problem for today's interaction. Let's try to learn something more. The question is, a particle moves along a straight line such that its displacement x is given as t cube, x or s you can say, minus 6t square plus 3t plus 4. T cube minus 6t square plus 3t plus 4. They are asking the velocity when acceleration is 0. So last time they asked you acceleration or retardation when velocity was 0. Now the question is exactly opposite. Determine the velocity when acceleration is 0. So velocity will be equal to dx by dt. So that will be equal to derivative of t cube is 3t square, minus 6 will stand as it is, t square derivative is 2t plus 3 will stand as it is, t's derivative with respect to t is 1 and 4 behaving a constant, constant's derivative is 0. Okay. So what you got is 3t square minus 6 into 2, 12t plus 3. Now if you are trying to get the value of acceleration, so that's going to be dv by dt. Acceleration is dv by dt. You will say 3 will stand as it is. T square derivative will be 2t minus 12 will stand as it is. T's derivative with respect to t is 1 plus 3's derivative with respect to t is 0. Okay, constant's derivative is 0. So the answer is 6t minus 12. Now what they are asking you? They are asking you velocity when acceleration is 0. So for acceleration 0, can I say 6t minus 12 is 0? That means 6t is equal to 12. That means t equals to 2 seconds. So at t equals to 2 seconds, the acceleration will be 0. But what they were asking you is determine the velocity when acceleration is 0. Acceleration is 0 when t equals to 2. And they are asking you determine the velocity when the acceleration is 0. So velocity when acceleration is 0 means velocity at t equals to 2. Velocity at t equals to 2 means where was velocity? Where is velocity? Here is velocity. Let's keep it here. You will say in place of t you have to keep 2. So 3 into t square means 2 square minus 12 into t means 2 plus 3. Simple. So see what you got. 2 square is 4, 4 into 3, 12 minus 24 plus 3. So 12 minus 24 is basically minus 12 and this minus 12 plus 3 is going to be minus 9 meter per second. So the correct result is minus 9 meter per second, option D. Again a neat PYQ. So see, on the day 1 of our bridge course interaction, you can easily do the neat questions, alright, which you are supposed to do after 2 years of learning. So that's what I meant at the starting of the session, that here you will keep smiling and keep enjoying your learning, and from day 1, whatever we as your teachers are mentoring and guiding you for different academic subjects, as well as how to attempt the question paper, that is going to benefit you throughout the 2 years and throughout the journey, academic journey of rest of your life also. Alright, so stay smiling, keep learning, enjoy the day, and make sure that before you sleep tonight, you do revise the things from the notes. Link you will get on the Telegram, and Telegram link is also attached in the description of the video, and after this session I'll get it done in this live session's description also. Alright, so all the best, thank you so much, and let's meet. See you on 3rd May. Let's meet on Wednesday 5:30 p.m. Alright, we will do integral calculus. All the best. Bye-bye.